Hello everyone from Math 1435, Pre-Calculus 2. Professor Wenson here again with a video on your KnewtonAlta homework. This is section 8.3 part 2. Compose functions with inverse trigonometric functions. Alright, so you saw in 8.3 part 1 all those 6 inverse trig functions, right? The inverse sine, inverse cosine, inverse tangent, and so on. The key to this section, 8.3 part 2, the key to this assignment is to remember that the inverse trig functions, when you take, the inverse sine of a number, or the inverse cosine of a number, etc., they represent angle measures. The output is an angle measure. So if you remember that, hopefully that will help you in this section. So here I have, evaluate composite functions with inverse trig functions of the form, f composed with f in. Now hopefully you remember what it means to compose two functions from maybe an algebra class or pre-calculus 1. I'm not going to go into all that. You should know what it means to compose two functions by now. So f composed with f inverse of x, or f composed with some other function's inverse, g inverse of x, like I have here. Alright, so I'm just gonna, you can click on more instruction. I feel like we know enough about the inverse trig functions to be able to do these right now. Alright. So again, the key is remembering that when you see an inverse, first off you got to remember what the range is, and also that it gives you an angle measure. Alright, so I'll do this on some paper, pull this up on a piece of paper. So we have here, we're asked in this first question to evaluate the cosine, right, this is regular cosine, of, and then an angle. Now the angle is written this way, it's the inverse sine of negative 20/29ths. So this inverse sine of negative 20/29ths, now first off, negative 20/29ths isn't a nice number that I know the value of the inverse sine off the top of my head. It's not like negative half or square root of 3 over 2 or square root of 2 over 2 or something like that, or 1 or 0. It's negative 20/29ths. But this inverse sine of a number, this inverse sine of negative 20/29ths, is an angle. It's an angle. And I'll give it a name, right? Just like I would with any angle. Say theta. And it's an angle theta that would be between, negative pi over 2 and pi over 2. Remember the range from section 8.3 part 1. Remember the inverse sine of a number will be an angle between, some angle between negative pi over 2 and pi over 2. From negative pi over 2 to pi over 2, such that, the sine is negative 20/29ths. Such that the sine of theta is negative 20/29ths. And since this is an angle, I can draw a picture of it. So off to the side here, I'm going to draw a picture of theta equals the inverse sine of negative 20/29ths. A picture of this angle in standard position. Alright, so remember standard position, you have your x-axis, y-axis. So I'm starting at the, the positive x-axis. Starting at the positive x-axis. Now, I'm looking for an angle between, again, between negative pi over 2 and pi over 2. That's what inverse sine gives me. An angle between negative pi over 2 and pi over 2. So that's quadrant 4 or 1 with a sine of negative 20/29. So it can't be an angle in quadrant 1. All right, if the sine of theta is negative 20/29 and theta has to be between negative pi over 2 and pi over 2, theta has to be in quadrant 4 then, where sines are negative. So I'm going to draw an angle, a negative angle, something from 0 to negative pi over 2. So some negative angle, there's a negative angle clockwise, that ends in quadrant 4. And this is theta. All right, this angle I have just drawn is my angle, the inverse sine of negative 20/29. It's what I'm calling theta. And then, as I've done plenty of times before, once this terminal side is drawn, this angle is drawn here, I take a point on the terminal side and I draw a perpendicular segment to the x-axis, right, to the horizontal axis, creating a right triangle. You see this right triangle here. And if you recall, again, hopefully you recall this. It might have been a little bit, but remember the sine of an angle is the y coordinate divided by the radius of some circle you're on, y over r. So the point here that I've chosen on this terminal side, well, let's say this has a y coordinate of negative 20, all right, because it's below the x-axis, and its distance from the origin, right, the radius of the circle it would be on, is 29. Okay, so I could even label this side here as being like negative 20, right, because it's down 20. So the only thing I don't know from this right triangle is this length. I don't know the x coordinate of the point I picked here on the terminal side, and I've got to find that, right? Because in order to find the we're asked for the cosine of this angle. Well, if I want the cosine of this angle that I'm calling theta, I need the adjacent length on the hypotenuse. I need x over r. So I want to find x, and that would be using the Pythagorean theorem here. Right? So I'm going to find x. So we'd have, x squared plus negative 20 squared, right? The sum of the squares of the legs will be equal to that hypotenuse, so that distance from the origin squared, 29 squared. So there's x squared plus 400 equals, let's see, 29 squared, 38 times 2, 76, 760 plus 81, 841. Just to double check, I'll pull a calculator up. All right. So 29 times 29, right? 29 squared. Yeah, 841. 841. Okay. So then we're getting here x squared equals, subtracting 400 would be 441. So x equals, plus or minus, but since this is to the right here, the x coordinate's going to be positive. I'm going to use the positive square root of 441, which is 21. All right, the square root of 441, and again, just to be absolutely certain, square root of 441 is indeed 21. All right, so back on my picture, this length here, this adjacent side to my angle, my inverse sine of negative 20/29, this has a length of 21 units. The x coordinate here is 21 for this point on the terminal side I picked. So I've got the x coordinate now, I've got the y coordinate, and I have, how far it is from the origin, that r. So now I can find anything. Right, and we're asked for what's the cosine of this inverse sine of negative 20/29, or what's the cosine of this angle I called theta. Again, theta, this is an angle that I called theta. And in my picture, the cosine of theta, the cosine of this inverse sine of negative 20/29, is x over r, adjacent over hypotenuse, 21 29ths. All right, and we could also, all right, I know this is kind of cheap what I'm doing now. We could also use the calculator to kind of double check this, check our work. So you see, what's the cosine of the inverse sine, right, of negative 20 over 29, and then I close the parentheses twice, right? And you see I get this crazy decimal, 0.72413. Let's see if that's actually equivalent to 21/29ths, what I said the answer will be. And look, it is. All right, so I've checked my work. It works out wonderful. Now back in the website, right, you're asked to provide your answer. Notice it doesn't say round anything. So you're not writing things as decimals here, just writing the fraction that I ended up with, right, 21/29ths. But the key, I hope you noticed that, the key to this was recognizing that the inverse trig function of a number, inverse sine of a number, inverse cosine of a number, is an angle, and you should then be able to draw a picture of that angle in standard position. You know what quadrant it ends in, set up a little right triangle, and all that. And then you're finding the cosine of said angle, the cosine on the outside there. See, great, and I think they go through that down here. Now they don't draw any pictures. I prefer pictures, but you can read their answer explanation here. All right. All right, so this is a different objective. There's only two objectives in this. See, this is the other way around. So, the last problem I showed you had, a regular function, cosine on the outside, and it was composed with an inverse trig function on the inside. This other objective is, the other way around, where I have an inverse trig function on the outside composed with a regular trig function on the inside. So you see the form f inverse of f or f inverse of g, where the inverse function is on the outside. Okay, so here, question. If a equals 16 pi over 3 radians, simplify this expression. Now, this can trip some people up. As you probably saw back in pre-calc 1 or some algebra class before this, that when you compose two functions that are inverses of each other, right? This is cosine in here. This is inverse cosine. They're inverses of one another. You might remember, hey, they undo each other, and I'm left with the input inside. These undo each other, and I'm left with a. So then you'd answer 16 pi over 3 and be done with it. Well, that's wrong. That's not correct. You got to pay attention to domains and ranges of these functions. All right. So I'm going to replace a with 16 pi over 3. Right? And what we're asked to evaluate here is the following. We're asked to find what's the inverse cosine of the cosine of a, and a, they said a was 16 pi over 3. Okay. Now again, the mistake, like I said, the mistake that people often make is this. They'll be like, hey, this is just equal to 16 pi over 3 because these are inverses of each other, so they'll undo each other. That's wrong. And the reason that's wrong is because you're doing the inverse cosine. Remember, when you take the inverse cosine of some number, right, you got something inside there. Remember, the output is an angle from 0 to pi. 16 pi over 3 is not an angle from 0 to pi. It's too big. That's way bigger than just pi, right? So that's why you're not just undoing these. The output, all right, the output has to be in the range of the first function. All right, so if I'm taking the inverse cosine of of something, the output has to be between 0 and pi. Right. So let me write a more general rule here. So in general, when you compose inverses, when you have f composed with f inverse or the other way around, as long as they're inverses, this will be equal to x, right? They will undo each other, but only if x is in the domain of the inside function right? You can actually plug it into the inside function, and it's in the range of the outside function. And that's not happening here. All right, so what we have to do first is evaluate, like you do with any composition. What is this value? All right, so I'm going to find this value first. What is the cosine of 16 pi over 3? Now, if you don't know what it is off the top of your head, you can maybe draw 16 pi over 3 in standard position. So I'm going to draw the angle, 16 pi over 3 radians. So starting in standard position here, now that's, 3 pi over 3, 6, 9, 12, and then 15. That's 15 pi over 3. And then one more pi over 3. So I'm in quadrant 3. Right? Quadrant 3. And in quadrant 3, the cosine of an angle is going to be negative. And the reference angle, right? The reference angle here is just pi over 3. So this again this is going back to like chapter 7 stuff. So like the cosine of 16 pi over 3. All right, this is going to be a negative number because I'm in quadrant 3 where x coordinates are negative, cosine be negative. And then what's the cosine of the reference angle? All right, now the cosine of pi over 3, that's the cosine of 60 degrees. That's just a half, so this is negative half. All right, so this now is what's the inverse cosine of, the cosine of 16 pi over 3 is negative half. And now I'm asked to evaluate this. And again, the output is an angle from 0 to pi. What angle from 0 to pi has a cosine of negative half? Well, that would be in quadrant 2, right? Just 0 to, that'd be 2 pi over 3. All right, we have the same reference angle. So this ends up being 2 pi over 3, right? Not 16 pi over 3. All right, and again, let me verify this with my calculator. Doesn't hurt to check. So I'll enter that the way it was. Right? We had the I am in radian mode, right? My outputs will be in radians for the inverse trig functions. So let's take the inverse cosine of the cosine of 16 pi over 3. Close those parentheses, and we get 2.09 blah blah blah. Now, like I said, that is not 16 pi over 3. Right? Let's see what 16 pi divided by 3 is. See, it's not that. That's too big. But is that 2 pi over 3? Let's take a look at 2 pi over 3. And oh yes, it is, right? 2.094395102 is the same. So yeah, you gotta be careful. Right? You gotta make sure that if you got an inverse whatever on the outside, that your final output is in the range of that function. Right, so like what I wrote over here. So back to the assignment, provide your answer below. They don't want a decimal, all right? They just want you to enter it as is, enter it exact. So 2 pi divided by 3. Okay. All right, and this is the other way around. We're back to the first objective where you have the the regular trig function. Oh, it looks like they have an inverse on the outside. Okay, so this time again we have the inverse on the outside. All right, so I'll go to a piece of paper. We'll do this one. So this time, the value of a is negative 13 pi over 4 radians. And we're asked to find the inverse cosine of, and then inside it, the sine of a, where a is negative 13 pi over 4. So again, just like the last problem, see how I'm taking the inverse cosine again of some number, right? What's in here, I'm going to figure out, right? This is some number. I don't know what it is. I'll figure it out in a second. But I'm taking the inverse cosine of some number. So my final output is going to be an angle from 0 to pi, right? This is again inverse cosine. So not negative and not bigger than pi will be my final output. All right, so let's figure this out. Let's try to find the sine of negative 13 pi over 4. So again, I'll draw negative 13 pi over 4 radians in standard position. So that's going clockwise. Right? So there's negative 4 pi over 4, negative 8 pi over 4, and negative 12 pi over 4, and then one more pi over 4. There's negative 13 pi over 4 that I've just drawn. And you see I'm ending here in quadrant 2. Okay, so the sine of this angle will be positive. Right? Remember, sine is related to y coordinates, and if you're in quadrant 2, sine will be positive because y coordinates are positive there. And what would be the reference angle? Right? The reference angle, this angle here between the terminal side and the x-axis, is just pi over 4, because I went negative 12 pi over 4 and then another pi over 4. So the sine of negative 13 pi over 4 will be positive the sine of the reference angle, which was pi over 4, and remember that was just the square root of 2 divided by 2. Alright, so what we're doing now is bringing this down here. This is now equal to the inverse cosine of the sine of negative 13 pi over 4 is square root of 2 over 2. And like I said, my final output is going to be an angle from 0 to pi whose cosine is the square root of 2 over 2, and that would be pi over 4. Positive pi over 4, 45 degrees. Again, let me just double check this. Let me verify it with my calculator. So again, I'm in radian mode. Let me clear the old stuff. I'm going to take the inverse cosine of the sine of negative 13 pi over 4. Close those parentheses, and I'm getting positive 0.7853 blah 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 blah. Hopefully that's pi divided by 4, like I have here. Pi over 4 is indeed the same value. So I did a good job. And that's what I'll enter also back on the website, right? Pi divided by 4. Right? So the pi symbol down here divided by 4. Right, great. And just doing a lot of the same. All right. So this is pretty similar. All right, I'll do this also. All right, now the g here is negative 37 pi over 4 radians. And you got the inverse on the outside again. Right? So back to a piece of paper. And I'll get rid of the calculator. I'll bring it back later to verify my answer. But we're asked to find now the inverse sine of the tangent of, and then g is negative 37 pi over 4 radians. Okay. All right. So this time, I'm taking the inverse sine of something. All right. Now this thing in here, this tangent of negative 37 pi over 4, that's going to be some number. All right, I'll figure that out in a minute. And we're taking the inverse sine of a number. Now the inverse sine of some number is going to be an angle. And it's going to be an angle from negative pi over 2 to pi over 2. Remember the range for inverse sine. All right, so first let me find this. What is the thing on the inside there? What is that tangent of negative 37 pi over 4? All right, so I'm going to draw negative 37 pi over 4, that angle in standard position. So again, this was negative, so you got, there's negative 8 pi over 4, negative 16 pi over 4, and then 2 more times will be negative 32 pi over 4, and then negative 36 pi over 4 plus another 4, and then negative 37. So I'm in quadrant 2. Right there. It's clockwise. Negative 37 pi over 4. Yikes. Okay. But I'm in quadrant 2. And then the reference angle is pi over 4. And I'm in quadrant 2, so tangents in quadrant 2, remember, are negative. So this tangent of negative 37 pi over 4 will be negative because I'm in quadrant 2. And then the tangent of the reference angle, right, the tangent of positive pi over 4. And what was the tangent of pi over 4? That was 1. All right, sine, because the sine and the cosine were the same. So this is negative 1. So now I'm taking, this is equal to now the inverse sine of negative 1. And then here's my output. My final output needs to be between negative pi over 2 and pi over 2. What's an angle from negative pi over 2 to pi over 2 with a sine of negative 1? That was negative pi over 2. All right, and let's again verify this with our calculator. So clear this. Let's go inverse sine of the tangent of negative 37 pi divided by 4. So it's negative 1.570. That is negative pi divided by 2. Right, let me double check. Negative pi divided by 2, exactly the same value. All right, well, it is for the first 5 decimal places. I know after a while, it's because of the way calculators do math. But they are the same value, trust me. All right, it's the first 5 decimal places. They're equal. All right. So this is it's only off here at the end again because of the way calculators round things. All right. But yeah, so we're looking good. Right, negative pi over 2, especially at these 90-degree marks. Negative 90 degrees. 90-degree marks are iffy for calculator work. So yeah, so back on the website, what I'm going to enter here is negative pi over 2. Wonderful. All right. I'm hoping to get another one where there's an inverse on the inside. All right, this one, also negative pi over 2. If I put in pi, right, the cosine of pi is negative 1. And we just saw the inverse sine of negative 1 is negative pi over 2. So this ends up being the same thing. So again, I'm hoping to get to one where there is an inverse on the inside. This again. Okay. Hopefully you remember. Look, if I put in 19 pi over 2 for n, see on the inside here, we're taking the tangent of 19 pi over 2. Remember tangent? Tangent was undefined at those odd multiples of pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2. There were, when you looked at the graph of tangent, y equals tangent x, there were asymptotes at x equals, those odd multiples of pi over 2. So this 19 pi over 2, that's an odd multiple of pi over 2. 19 is an odd number, right? So this is undefined. You cannot take the tangent of 19 pi over 2. So we're going to enter this. So if it is undefined, we're going to enter this circle with a slash through it, like the empty set thing, and that's this guy right here. All right. Another one. All right, so I've already done several like this. Now this is in degrees. All right, this is in degrees, so you gotta be careful with this one. You gotta make sure your answer is in. Now it says don't put the degree symbol, but if you're punching this in your calculator, you'd have to make sure you're in degree mode, so that what gets spit out to you is degrees. But I'm just gonna go cheat on this one because I've done some like these already. Here's another one like that. Why are they all like this? So I put in 19 pi over 3 for C. Find the sine of 19 pi over 3. Let's see, 19 pi over 3. Right, if I were to draw that in standard position, well, you'd have 6 pi over 3s once around, then 12 pi over 3 would be twice around, right, because each one of those 2 pi. That would leave me with 7 pi over 3. So, 18 pi over 3 would be 3 times around. I'm back to the beginning, then another pi over 3. So you're in quadrant 1. And that's positive. So sine is positive, and your reference angle is pi over 3. The sine of pi over 3, the sine of 60 degrees is square root of 3 over 2. And the inverse cosine of square root of 3 over 2, again, you're thinking inverse cosine. That's an angle from 0 to pi with a cosine of square root of 3 over 2. That would be pi over 6. This one ends up being pi over 6. And, I would draw pictures normally, but I know what I'm doing. So, oh, come on, submit, thank you. Yeah, well, I guess with enough practice, you should be able to visualize this stuff in your head. Yeah, that's it. Alright, so hopefully you come across more problems like the first one we had. Alright, that first one we had. Alright, let me see if I can pull that up again. Here it is. This one. You just got to remember, if the inverse is on the inside like this, the inverse trig function of a number, right? The inverse trig function of a number is an angle. So you're taking the cosine of an angle, and if that's an angle, you can draw a picture of it and set up a little right triangle. So if you come across problems like that, hopefully you'll know how to tackle them. Right? I mean, you've seen in other videos on other assignments, I don't cover every single scenario you're going to come across. I get an example or two of problems you'll come across. So looks like this time through I only came across one example of this kind of a problem. So hopefully when you come across other ones like this, you'll have an idea as what to do. Now, if there's a special number inside, like if this was the inverse sine of square root of 3 over 2, I wouldn't need to draw a picture. Because, the inverse sine of square root of 3 over 2 would be pi over 3, and then the cosine of pi over 3 would be a half. Like if there's a special number inside it, you don't need to draw pictures. But if there's not a nice number, like, negative 20/29ths like this, then perhaps, you should draw a nice picture of that angle. All right. So hopefully this guides you a little bit through section 8.3 part 2's homework when you go through it yourself. Obviously, if you have any issues or questions, let me know. And thank you very much for watching.